Good morning. This isn't ideal, but what I'm going to do is explain Lab 4 subroutines to you. Unfortunately, I can't be in the lab today. My son has a fever and was throwing up all night. This is about the best I can do. The lab should be open for you, and hopefully I can explain any problems you may have away in this video. The lab is about subroutines. What you're going to do is ladder 2, subroutine 2 is automatically generated for you. You're going to create two new subroutines, 3 and 4. 3 is going to be labeled manual, 4 is going to be labeled auto. That's done by just going right side mouse on program files and saying new. What you're going to do is in ladder 2, here you're going to put jump to subroutine or JSR commands that choose which one of these two to run, and that's based on selector switches. So if you have selector switch I:0/6 on, so if this selector switch is on, you run manual. And the manual one's really straightforward. In the manual subroutine, all you want is literally press button, turn on light. So button 0 turns on light 0, button 1 turns on light 1, button 2 turns on light 2, and so on down the line. Pretty straightforward really for ladder 2, or for manual. Auto, unfortunately, is not quite as straightforward. If you turn on selector switch I:0/7, then you're going to run the auto subroutine. And the idea is instead of controlling the lights manually, you're going to control the lights here using a timer. They're automatically controlled. And the way this is going to work is if you have I:0/8 on, what we want is the lights to flash at 1 second intervals, and we want them to go in increasing order. So run from 0 up to 5. So it goes 0, 1 second later, 1, 2, 3, 4, 5, and it rolls back to 0 and just keeps running that loop continuously as long as 8 is on. Again, this is similar to labs we've done before where it just counts up continuously. In auto, if you have I:0/9 on, it's the same 1 second interval, so the lights are on for 1 second and then the next light turns on. But the difference is if 9 is on, we want it to go in reverse order. So it starts at output 5 and it turns on 5, 4, 3, 2, 1, 0, goes back to 5, 4, 3, 2, 1, 0, and so on. So basically, one selector switch causes the lights to flash at half-second intervals moving forward. One causes the lights to flash at half-second intervals moving backwards. The subroutine part's easy. It's this flashing that tends to be hanging people up the most. So what I'm going to do is give you a quick explanation of how to do that. My quick explanation is going to be, first of all, what you need half on and half off. So you're gonna need to set up a bit that pulses for 1 second on, 1 second off, 1 second on, 1 second off. Right, and then you can use this bit to pulse counters and pulse the lights. Your best way to set this up is by setting up a simple rung with 2 timers. Right, and these are both done bits. This one is a done bit from this timer. So if this is timer 1, this is timer 1 done, this would be timer 0 done. The idea is this timer runs right away. When this timer is done running, this timer runs. When this one's done, it resets everything and starts over, which means one timer is handling on and one timer is handling off, and you now have T4:0/DN that's flashing at half-second intervals. When you have that, you can now use that T4 done, put it in a branch that says count up, or the other option would be count down. It's your choice if you want it to count up or down, and that choice then could be made by putting selector switches here and having that T40 DN here. So this is pulsing. and this just chooses which one of these I pulse, and of course these would both be the same address. Right? So now what we're doing is we have a pulsing bit. When I choose the subroutine, I have a pulsing bit that either pulses up or down this counter accumulated, depending on which selector switch is on. When you got that, now it's as easy as an indirect address, right? Now we can, like we've done in other labs, you can go output :0 / indirectly address C50.acc. And what this will do now is take whatever this counter accumulated is at and either increment this, turn on the appropriate light. Some of the challenges you're going to face, oh, I'm out of paper. Some of the challenges you're going to face are, remember, this leaves the light on, so you're going to have to do, like we did in the previous lab, use the clear command to clear the outputs in advance of this. So you're going to clear it and then turn on your output. The other problem is that you're going to need to establish some limits or some way to reset this counter. Of course, remember, if we're talking about reset, what we're saying is if the counter is going up, when the counter is greater than, I forget what greater than is. I think it's greater than, whatever the greater than command is. When it's greater than 5, you're going to want to move 0 back into the accumulated, right? If it's less than 0, you're going to want to move 5. So you're going to have to write rungs that say if the counter accumulated is greater than 5, move 0. If it's less than 0, move 5. What these two commands are going to do is cause it to continually roll around, you know, either counting up or counting down, depending on which way you have it set. This is in essence a reset. One word of warning, a scan issue. If you try to turn, if this accumulated at -1 and you run this, you're going to get a fault. So this reset option needs to be in your logic before this output. That way you reset it at -1 prior to turning on this output. I realize this is a quick brush through things. Hopefully it makes some kind of sense. Rewind it, fast forward it, whatever you need. I will be in late this afternoon to help out a little bit if you're still in the room. I should be in around 1:30, 2 o'clock. And if not, certainly next week we're going to knock this lab off without any trouble at all. Hope this video made some kind of sense. Feel free to work with your classmates, and hopefully this will help a bit. Thanks.